The upgrade we have this time is a speaker, microphone, timer, and oscillator. After 10 seconds, controlled by the 555 timer, the speaker will produce ultrasonic wave in order for the speaker to catch it and measure the distance. So the ultrasonic wave produced by the speaker has different amplitude while the speaker is in different location. So we can measure the distance with that signal. So we have an oscillator in our circuit composition. It is basically a comparator. In our capacitor side, when the capacitor charge or discharge, it's gonna affect the oscillator, the state of the oscillator. So it's gonna make the oscillator bounce back and forth between two states. So the charge and discharge rate of the capacitor is gonna determine how fast the oscillator oscillates. We have a 555 timer. So what it does, it's gonna pass 10 seconds and then we proceed to the next stage. So originally we wanted to have 30 seconds, but we have 10 for now.
Right, so this is a relaxation oscillator at the bottom, which is used to sending a oscillating frequency into our speaker using a 200 ohm resistors and a 0.01 microfarad capacitor. And that's sending the signal from this black wire into this potentiometer, which can be used to adjust the volume of the signal. That is sending it output into a single transistor amplifier, which just uses two capacitors and a series of resistors to amplify the signal to the speaker, which is currently producing a signal, but it just can't be heard because it's an ultrasonic signal. This microphone is currently not working, but hypothetically would be receiving the signal, even though we can't hear it, and we would be able to read it by measuring the voltage across this port right there, but currently the microphone is fried, so that doesn't really work right now. And this microphone would be powered by a 555 timer, which it is currently set up and working, and it would be able to work for approximately 10 seconds upon the push of a button, but the microphone doesn't work, so we just used an LED to substitute to show that that was working. And I can show you the signals going through the oscillation. I'll show you the oscillation frequency right now. You can see that it currently does have a period of about 50 microseconds, and it is an oscillating pulse wave, but it does produce a fairly consistent sine wave. And we can see that the speaker signal is this. Oh, wait, that's actually upside down. Let me fix that very quickly. Switch the voltmeter. There we go. Yeah, that should be the correct signal.
So we'll implement a timing circuit to limit the amount of time people have on the game, and also to motivate them to go faster. So if we run this timing circuit, so the capacitor starts charging once the circuit starts running until it reaches 3.3 volts. It starts charging, and when it starts charging, the output is set to high until it reaches a certain output until the capacitor reaches 3.3 volts, and then once it starts discharging, and once it starts discharging, the output is set to low. And if you want to check this, you can look at the first. We can check the voltage across the capacitor. As you can see, it starts discharging at 3.3 volts, and then if we check the voltage across the diode, we can see it's hot when it's high. When the capacitor is charging, you can see it's high. Once it starts discharging, it becomes low, which is approximately 14 seconds. This is going to give people 14 seconds to leave the game, to play the game actually.